You know that feeling, right? You land after a long flight, you grab your bags, and you pull out your phone to get an Uber. And you just wonder, how does it know? How does it know there's a car just a few minutes away? Or for the driver, how long they're actually going to be waiting in that long line of cars? Well, today, we're going to pull back the curtain on the incredible tech Uber uses to predict your airport wait time. It's a fascinating system, so let's dive.
So, it all starts with this one massive, chaotic challenge, the airport. For a company like Uber, airports are a huge deal, but they are also wildly unpredictable. You've got this constant, high-stakes balancing act between how many drivers are there waiting and how many people like you are walking out of the terminal needing a ride.
So for a driver, this waiting lot, this is their office. They're sitting there in what's basically a first-in, first-out line. But the question that's constantly running through their head is, how long am I going to be here? Is it a quick 10 minutes, or am I stuck for over an hour? Because in their world, every minute they're not moving is money they're not making.
And this really gets to the heart of the problem. It's a two-sided nightmare. On one hand, you get an oversupply. Way too many drivers, not enough flights landing. Those drivers are just stuck, burning gas and wasting time. But on the other hand, you get an undersupply. A flood of passengers hits the curb and there just aren't enough cars. And you know what that means for you. Long waits and, yep, surge pricing. Either way, someone's having a bad time.
So, faced with this constant push and pull, Uber figured out that the best weapon against all this uncertainty is information. If they could just give drivers a clear, reliable idea of what to expect, they could make smarter decisions. And that meant they had to figure out how to predict the wait time. And this is it. This is the solution, right in the driver's app. It's a simple little tile that gives them a heads up. The wait is short, medium, or long. Suddenly, a driver isn't guessing anymore. They can look at this and think, okay, it's a long wait. I'm out of here. I'll go find fares in the city. Or, awesome, short wait. I'm sticking around. It's a total game changer. Which, of course, brings us to the million-dollar question. How on earth does it know? I mean, this isn't just a lucky guess or some simple average. No way. It is the output of an incredibly sophisticated forecasting engine humming away behind the scenes.
The secret sauce here is a really clever three-part model. You know, instead of trying to tackle one gigantic, impossible problem, Uber's engineers were smart. They broke it down into three smaller, much more manageable pieces that all work together.
And here's the game plan. It's super logical. First, the system has to figure out how many drivers are actually in line right now. Second, it basically looks into a crystal ball to predict how many ride requests are coming down the pike. And third, it smashes those two things together and runs a quick simulation to see how fast that line is going to move. This visual just lays it out perfectly. You've got your supply data flowing in, your demand forecast flowing in. They both feed this simulation engine. And what pops out at the end? That simple little message that shows up on the driver's phone. So let's zoom in on that first piece, the supply model. Now, you might think, can't you just count the cars? Well, not really, because that queue is a living, breathing thing. Drivers might get fed up and leave. Other drivers might have priority status and jump the line. So this model has to account for all that chaos to get the true number of cars in the queue. Next up, the demand model. This is where things get really cool, because the system is literally trying to predict the future. It's not just guessing what's happening right now. It's forecasting how many rides will be requested in 15-minute chunks over the next hour or so. So how does it pull that off? Well, it's a data detective. It's looking at everything. It's checking flight schedules, because a 747 just landing means a huge wave of potential riders. It's looking at the weather. You know, a sudden downpour can send demand through the roof. It's even looking at how many people are just opening the app or searching for prices near the airport. All these little signals get crunched together.
And finally, the system puts it all together in the simulation. And don't let that word simulation fool you. It's basically just some smart, fast logic. It asks a simple question. Is the demand we're expecting in the next 15 minutes bigger than the number of cars we have? If the answer is yes, boom, short wait. If it's no, it does the math and asks the same question for the next 15-minute block, and so on, until it knows how long that last car in line is going to have to wait. Okay, so having a great idea for a model is one thing, but actually building the technology to make it work in real time for every major airport on the planet all at once, that is a completely different beast. We are talking about a true data flood.
And yeah, I know, this looks incredibly complex, but don't worry about reading all the boxes. Just think of this as the digital plumbing that makes it all possible. It's the system that takes all those different data streams we talked about and funnels them down to deliver one simple, accurate prediction to the driver's phone in seconds.
Now, if you zoom in on just the demand forecasting part, you can see the real headache. The number one challenge here is timing. You have all these real-time signals coming in, flight landings, weather updates, app openings, and they have to be perfectly synchronized. If the timing is off by even a minute, the entire prediction can be thrown off.
And hey, don't just take my word for it. The Uber engineers who built this whole thing said that getting all those signals lined up in the right order was, and I'm quoting them here, quite challenging. Now let me tell you, in engineer speak, that's basically them saying this was ridiculously hard.
So, after all that brilliant data science and mind-bending engineering, what's the point? Why does all of this matter? Well, it all comes down to creating smarter queues. And smarter queues mean better trips for absolutely everyone involved.
The impact here is really significant. For drivers, having this transparency means they waste less time, which means they can earn more money. And for riders like us, a balanced system means we get more reliable pickups and probably wait less time on the curb, even when it's super busy.
At the end of the day, this is a perfect example of what technology does best. It takes a massive, messy, chaotic flood of data and transforms it into a single, simple, actionable insight on a screen. By empowering drivers with better information, Uber makes the entire airport ecosystem work just a little bit better.
So what's next? Right now, this tech is all about the driver's experience once they're already at the airport. But imagine if this system could get so good that it could predict demand hours, or maybe even a whole day in advance. What if your app could give you a little nudge and say, hey, you should probably leave for the airport now to avoid the rush? That's the kind of future this incredible technology could unlock.